the integrated circuit patent, U.S. Patent number 3,138,743, issued to Jack Kilby in 1958. Welcome to Patentomatics. In today's video, we will talk about the integrated circuit patent, U.S. Patent number 3,138,743, issued to Jack Kilby in 1958. So before this video starts, please share, like and subscribe to our YouTube channel for more updates. In 1960, an integrated circuit, IC, chip that was planar and monolithic was exhibited for the first time. In 1949, German physicist and engineer Werner Jacobi developed and patented the first known integrated transistor amplifier. In 1952, British radio engineer Geoffrey Dummer proposed integrating a variety of standard electronic components in a monolithic semiconductor crystal. These two events led to the conception of the idea of integrating electronic circuits into a single device. Once another year had passed, Harwick Johnson submitted a patent application for a prototype integrated circuit. Similar chip designs were developed by Sidney Darlington and Yasuo Terui of the Electrotechnical Laboratory between the years 1953 and 1957. With these designs, many transistors might share a shared active region, but there was no electrical isolation to separate them from one another. The business sector was unable to put these concepts into action until late 1958, when a breakthrough finally occurred. Integrated circuit production was hampered by three fundamental issues, and these issues were solved by three persons working for three different firms in the United States. Jack Kilby of Texas Instruments was the one who patented the notion of integration, developed the prototype integrated circuits, ICs, and brought them to market. It was a hybrid integrated circuit, hybrid IC, chip that was invented by Kilby, not a monolithic integrated circuit, monolithic IC, chip. Kurt Levesque of the Sprague Electric Corporation devised a method to electrically isolate components on a semiconductor crystal using p-n junction isolation between the years 1958 and 1959. Robert Noyce of Fairchild Semiconductor is credited with inventing the first monolithic integrated circuit chip. He devised a method for connecting the IC components using aluminum metallization, and suggested an enhanced form of insulation based on planar process technology created by Gene Horney. Both of these innovations were based on the same technology. On September 27, 1960, a group led by J. Last at Fairchild Semiconductor developed the first functioning semiconductor integrated circuit, IC, by applying the concepts proposed by Noyce and Horney. An agreement on cross-licensing was reached in 1966 to bring an end to a patent war that had been begun by Texas Instruments, which was the owner of the patent for Kilby's idea at the time. Nobody can agree on who came up with the idea for the integrated circuit. Kilby and Noyce were the only two people on the list by the time the 1970s rolled around, even though the American press of the 1960s identified four individuals: Kilby, Levesque, Noyce, and Horney. Kilby was recognized for his involvement in the invention of the integrated circuit, and was given the Nobel Prize in Physics in the year 2000. In the 2000s, historians Leslie Berlin, Bo Lojek, and Arjun Saxena amended the contribution of Kilby while also reinstating the notion that numerous people were responsible for the invention of integrated circuits. Instead of being built on Kilby's hybrid IC, modern IC chips are developed using Noyce's monolithic IC. The concept of integrating. In 1949, a German engineer named Werner Jacobi, Siemens AG, filed a patent for a semiconductor amplifying device that was similar to an integrated circuit. The device depicted 5 transistors on a common substrate arranged in a 3-stage amplifier arrangement, with 2 transistors working upside down as an impedance converter. These early developments led to the creation of the integrated circuit. Jacobi described hearing aids that were both compact and affordable as an example of a typical industrial application of his patent. It does not appear that his patent will be put to quick use in the commercial sector. In a public address given in Washington on May 7, 1952, the British radio engineer Geoffrey Dummer first articulated the concept of integration as follows: as a result of the development of the transistor and other advancements in semiconductor technology, It is now conceivable that electronic components may be integrated into a single block, without the need for any wires to connect them. The block may be made up of layers of insulating material, conducting material, amplifying material, and rectifying material, with the various electrical functions being connected by cutting out sections of the various layers. Although they all used a thin strip of semiconductor material with a bipolar transistor attached to one end, the processes by which the transistor was manufactured were rather different. The strip performed the function of a series of resistors. The lumped capacitors were created through the process of fusing, whereas the inversely biased P-N junctions performed the function of dispersed capacitors. Johnson did not provide a technological procedure, and it is unknown whether he created a gadget during his time at the company. In 1959, a variation of his plan was put into action by Jack Kilby, who also received a patent for the invention. Jack Kilby is credited with integration. Kilby's hybrid integrated circuit was used. Jack Kilby, a seasoned radio engineer who had served in the military during World War II, began his employment at Texas Instruments in May 1958. At first, he was not given any specific assignments, therefore he was responsible for selecting an appropriate topic that fell under the umbrella concept of miniaturization. He had the opportunity to either discover an entirely new research path, or integrate himself into a multi-million-dollar project involving the fabrication of military circuits. Either way, he stood a good chance. Kilby came up with these three characteristics of integration during the summer of 1958. The only item that a company that manufactures semiconductors can create with any level of success is the semiconductors themselves. Semiconductors can be used to create every component of an electronic circuit, including resistors and capacitors. Just the interconnections need to be added after all of the circuit components have been created on a single semiconductor crystal. Kilby gained authority on August 28, 1958, to implement the prototype of an integrated circuit that he had built using discrete components. This prototype was assembled by Kilby on August 28, 1958. He had access to technologies that could form mesa transistors, mesa diodes, and capacitors based on P-N junctions on a germanium, but not silicon, chip, and the bulk material of the chip could be used for resistors. He did not have access to technologies that could form P-N junctions on a germanium chip. The typical size of a chip produced by Texas Instruments was 10 mm by 10 mm, and it contained 25 mesa transistors arranged in 5 by 5 arrays. Kilby sliced it up into 5 transistor 10 mm by 1.6 mm strips, although he only ended up using a maximum of 2 of those strips later on. On September 12, he presented the first IC prototype, which was a single transistor oscillator with distributed RC feedback. He did this by duplicating the idea and the design from Johnson's 1953 patent on the integrated circuit. On September 19, he constructed the second prototype, which had a 2-transistor trigger. In his United States Patent Number 3-138-743, he described these integrated circuits and referred to Johnson's work. Between February and May of 1959, Kilby submitted several patent applications, including those for the United States Patent 3-072-832, United States Patent 3-138-743, United States Patent 313-8744, United States Patent 321-5581, and United States Patent 326-1081. Although the patent itself and the book written by Kilby placed the application date on February 6, 1959, the application archives at the Federal Patent Office were unable to verify this information. According to Arjun Saxena, the application date for the important patent 313-8743 remains unknown. He hypothesized that the initial application was submitted on February 6 and was misplaced, and that the preserved resubmission was received by the Patent Office on May 6, 1959, the same date as the applications for patents 307-2832 and 313-8744 respectively. On March 6, 1959, Texas Instruments made Kilby's ideas available to the general public for the first time. the problem of component isolation and interconnection was not addressed by any of these inventions. Instead, the components were segregated from one another on the chip by milling grooves, and they were connected using gold wires. Hence, these integrated circuits were of the hybrid variety rather than the monolithic kind. Kilby, on the other hand, provided evidence that numerous components of a circuit, including active components, resistors, capacitors, and even minuscule inductances, could be created on a single chip. A historical account of the development of the innovation. Kilby and Noyce are the names of two inventors. During the patent disputes of the 1960s in the United States, both the professional community and the press became aware of the possibility that the number of IC innovators could be quite high. Kilby, Lévesque, Noyce, and Horney are the names of 4 individuals that are mentioned in the book Golden Age of Entrepreneurship. Sohrab Gandhi wrote in Theory and Practice of Microelectronics, 1968, that the patents of Lévesque and Horney were the high point of semiconductor technology in the 1950s and opened the way for the mass production of ICs. Gandhi said this about the fact that these patents made it possible for ICs to be manufactured in large quantities. Kilby and Noyce were presented with the Ballantine Medal from the Franklin Institute in October 1966. The medal was bestowed upon them for their major and fundamental contribution to the creation of integrated circuits. This event was the impetus for 2 people to come up with an idea. Kilby's nomination was met with opposition by contemporary individuals, who did not acknowledge his prototypes as genuine semiconductor integrated circuits. The engineering community was well aware of the role that Moore, Horney, and other key inventors played, whereas Noyce, at the time of his invention, was the CEO of Fairchild and did not participate directly in the creation of the first integrated circuit, IC. This made the nomination of Noyce even more controversial. Noyce acknowledged it himself: "I was attempting to find a solution to a production issue. I had no intention of constructing an integrated circuit." The two-inventor view was widely accepted by the time the 1970s came to a close, and the disputes that took place between Kilby and Lévesque in professional journals between the years 1976 and 1978 did not alter the position. Horney, Last, and Lévesque were considered minor participants because they did not represent significant firms and were not interested in debating public priorities. How did you like the video? Do you like it? Leave your valuable comments in the comment section below, and don't forget to like, share, and subscribe to our channel Patentomatics on YouTube.